Dave, you guys at Vectron International are in the business of making rocks that wiggle. Now, that doesn't sound very high-tech, doesn't sound very innovative, but it's obviously crucial to all electronics. Right. And it's actually very high-tech.
Yes.
Tell us a little bit about what you guys do.
So all of our products start with a quartz-based product. This is a synthetically grown quartz crystal. In the middle of this, there's a seed. This seed is then put in an autoclave, and this crystal is the result of probably about a 4 to 6 week process of growing the crystal. From that, these crystals are cut on a very specific angle off of this seed and ultimately make their way into the final crystal device and then into our oscillators. The real black magic of this whole thing is to take this, polish this, process this crystal to the point where it is finely tuned for a specific frequency and a specific application. And then electrodes are placed on both sides of this crystal, it's energized, and that oscillation produces a frequency. And then that device is then used and put into an oscillator circuit around it for various applications.
So every kindergartner or second grader knows about crystals because you grow them. Natural crystals are just not pure enough, right? So that's why you grow these.
Absolutely. Natural crystals have way too many impurities. The processing of them, there is no seed per se to come off of on the angle, so very tricky. The first guy who decided to put an electrode on a crystal is an absolute genius, but the frequencies that they were able to maintain are nothing like what we can do today.
Right, right. And oscillation was discovered how long ago? A long time ago.
I think back in 40s and 50s, right around the end of the Second World War. This particular area grew up. There's a couple crystal valleys, if you will, that popped up around the world. This is one of them, and this particular area had many different crystal manufacturers, oscillator manufacturers back in the day. We're really the last one in this specific area, or other factories in Germany are also in another, what they'll call Crystal Valley. But it's very old. 40s and 50s is really when it started to take off, and from there we've grown to what we are today.
So let's talk about that a little bit, how you take this inert object and turn it into systems, subsystems that go into, as I understand it, everything from aircraft to satellites to computers to test equipment, all down the line.
That's right, all the way through the telecommunication, industrial product spectrum, and military and space applications. So what we'll do is, once we finish this crystal, we'll package it or leave it as an exposed blank and build it into an oscillator circuit. And in that oscillator circuit, again, different applications, different processing, but generally speaking, we'll take that finished crystal at a very specific frequency. We'll build the oscillator circuit around it, add whatever other circuitry is required for the customer. It produces an output, essentially just a frequency, or in some cases digital even these days. And then the customers use that in a lot of different ways. In telecommunications, we're often helping with the timing and switching, also as reference backups to GPS receivers, that kind of thing. We can also be used as filters for frequencies in military applications, jamming devices, those kinds of things, and also to clean up signals, any RF signals.